My name is Winslow Harrington. I'm the Chief Building Engineer of the Public Theater in Manhattan. I took BOC1 in spring of 2016. Understanding the systems in my building better helped me understand the opportunities for energy savings. To save energy in a building, you need to understand the systems. In your classes, you'll learn more about how building systems work. Building systems require heating, cooling, air handling, lighting, and electrical power. I'm going to walk you through my building to show you the different systems that are important to energy efficient operations. We need to supply heat to the building. There are various ways to do this. Our building has a boiler. Our facility uses natural gas. The boiler accounts for the majority of our gas usage. Boilers can generate steam or hot water. This is a steam boiler. This is the burner that burns gas to create heat. The motor serves to provide combustion air to the fire. Steam is delivered by piping to terminal units such as radiators or heating coils to transfer heat. In the boiler room, we also see supply piping and return piping. These circulate the steam to the terminal units and carry the condensed steam, which is water, back to the boiler to be heated again. The condensate receiver collects that water, which is important for efficient boiler operations. Ours uses a vacuum system. Others use pumps or just gravity to collect the condensate. Types of terminal units can include radiators and heating coils, such as fan coil units or an air handler. These are all connected by piping to the boiler. Not all buildings have all of these. We provide cooling during the warmer months, and to achieve that, we use a chiller system as well as the cooling tower and package units that provide cooling throughout the building. To reduce energy consumption in the building, we use the control system to optimize the cooling by scheduling the systems to help reduce energy usage and electricity usage in the building. Cooling uses electricity. Electricity is expensive, and this is a good place to save on costs. The chiller is a major piece of equipment that makes chilled water and provides cooling throughout the building. Chilled water moves through the pipes and pumps to the various conditioned spaces throughout the building. Condenser water moves through the return and supply piping to the cooling tower where heat is rejected to the atmosphere. There are many different configurations of cooling towers. Package units provide heating, ventilation, and cooling all in one system. Cooling coils are the main terminal unit for cooling systems. Some rooms use supplemental units to cool their space. You don't have to worry about them unless they're major load items. In addition to conditioning the air, you have to find a way to circulate it throughout the building. The air handler circulates and conditions the air used to heat, ventilate, and cool the space. Ventilation air is fresh air brought inside of the building. We may mix this air with air returned from the building and heat and cool it as needed. Here is the chilled water going to the cooling coil, and here is the return going to the chiller. This air handler uses natural gas to heat the air. Some air handlers use steam to provide heat. It takes a lot of energy to condition outside air. Fans also use a lot of energy to move air throughout the building. Here are the ducts that carry the conditioned air from the air handler to every part of the building. Lighting is critical to occupant satisfaction. Controls and scheduling of lighting is a potential source of significant energy savings. We have lights throughout the building, both inside and out. There are many types of fixtures, which each have their own power needs. Some lights are more efficient than others. Lights left on when not needed are always a waste of energy. Lights are turned on and off by switches. Some switches are smart enough to control lights based on occupancy or available daylight. Electricity powers many devices in building systems, such as motors and pumps, fans and chillers, and all lighting systems. Electricity is expensive, so you need to understand how it is used and where there are opportunities for savings. It is also very dangerous. You should only open electrical panels if you are properly trained and equipped. Some of these should only be opened by a licensed electrician. The electrical room is where all power enters the building for conditioning to run different building systems. This is the service entrance. This is where power comes into the building from Con Edison. This is the meter. This is how Con Edison measures energy consumption coming into our building on a monthly basis. The main disconnect switches are where all power can be turned off to the building. These are the main distribution panels. Here is where the power is routed to specific systems. These can each have their own disconnect switches. Let's leave the electrical room and look at some more electrical components. If the power to the building is cut off unexpectedly for any reason, the automatic transfer switch disconnects from the grid and connects to an internal generator to provide electric power for emergency and basic systems. Wiring carries electricity to end-use loads such as motors, lighting, and other devices throughout the building. Transformers may be used to raise or lower voltage as needed for different systems or devices. Not all buildings have these. In addition to the main disconnect, there are safety switches used to disconnect specific equipment or groups of equipment for servicing. Electric lighting panels distribute power to lighting fixtures. In some buildings, all of these systems are controlled by Building Management System or BMS. These can control schedules, set points, and other operational parameters. By using your BMS effectively, you can manage and reduce energy use in your building. That's my building, the Public Theater. I'm sure you have similar systems inside of your building. Understanding my building has helped me do a better job in running it more efficiently. After taking BOC 1, I worked with my team to implement energy efficiency planning. With the whole team on board, we were able to run the building to occupancy level, which resulted in $107,000 in energy savings in 1 year. I definitely recommend taking some time to get familiar with your own building systems. This will really be useful as you dive into the details of how your building operates and you identify opportunities for efficiency improvement. Having a good understanding of your systems will allow you to run your buildings more efficiently.